realized I was muted. Hi.
Hi.
Yeah, I'm glad people showed up. Hi. Sometimes I'll host sessions and nobody shows up and I'm like, okay. So I close it after 15 minutes.
I want to say thank you for holding it in the evening. It makes it a little bit easier.
Oh,
I know
okay.
it's hard and I know everybody's schedule is different, but yes, thank you.
Yeah, no, it was random. I was looking at like the test scores. I was like, all right, I have time today, so let's see what happens. I'm recording and that way I'll post this on Canvas. Wait like another minute or so. Oh, do you guys have like specific questions that you want to ask? Or do you just want me to like randomly do math stuff?
I don't have anything specifically. The only thing that does throw me off sometimes still is like the amount of decimal places.
Okay, decimal places. Andre?
Same,
Only.
same with the significant amount of numbers.
Mm-hmm.
So significant figures.
And then I get confused where it's like, okay, we're supposed to be doing this all the time when we multiply, divide, add, and subtract, right? It should always be.
Yeah, so okay, I'll go over that. I'll go over the rules and then how to apply this, how to apply significant figures when it comes to calculations and reporting our answers. So I'm gonna share screen. Let's see this screen, right? Where I wrote significant figures down.
Yes.
Okay. So significant figures, it's like basically just asking how many numbers actually matter when it comes to accuracy. So remember there was accuracy and there was precision, right? So any number between 1 through 9 is considered significant, right? Or less than 10, if you want to say. So and what I mean about any numbers like 1, 1.1, 1.2, 0.5, you know, so they're all significant if you have a whole number. So whole numbers are significant. Right, so that's the easy one. And then the one that gets people are the zeros. Okay. So which zeros are significant and like which zeros are not significant. So in order for a zero to be significant, it has to be between whole numbers. And so what that means, it's like it's sandwiched between. So like, if you see that zero, it's sandwiched between whole numbers, right? So it's significant. You know, and there could be as many zeros as need be in there, and they're significant. All of them will be significant. So this has 3 sig figs, and this one has 1, 2, 3, 4, 5, 6 sig figs. Am I writing big enough for the screen?
I could see it good.
Yeah, I can see it.
Okay. All right, so zero sandwiched between the whole numbers are all significant. Now, zeros are also significant if they are after a whole number and there is a decimal anywhere. So after a whole number and if there's a decimal anywhere. So that means the following: 1.0, that zero is significant, right? 200, those 2 zeros are significant. So This has 2 sig figs. This one has 3 sig figs. If I had 200.00, these are also significant because they're all after a whole number, right? So they're after a whole number and there has to be a decimal point somewhere in them for them to count as significant. So how many sig figs do I have here?
Would it be 5?
Yeah, 5. 1, 2, 3, 4, 5. 5 sig figs. All right. So then we're gonna look at the ones that are not significant, and it's easier to remember the ones that are versus the ones that aren't, right? So this is everything that's significant. The ones that are not, so significant are leading and trailing zeros. So that's leading are zeros that come before a whole number. So all of these are not significant. They add to the precision, but not to the accuracy of the number. So these are called leading zeros, and trailing zeros are, for example, like this. There's a comma, but there is no decimal. So if I look at this number, how many significant figures do we have?
Would it be 6?
Nope, because what are these zeros?
Okay, so it would only be 3.
Only 3. They're leading.
They're leading.
What will make these zeros significant?
So they wouldn't be significant because, but I thought if it has a decimal point, it would make them significant.
So the part that I highlighted, it's zeros after a whole number. So there has to be a whole number in front of them, and there's no whole number. There's only zeros in front of these zeros. The whole numbers are after, so therefore none of these are significant. So there's only 3 sig figs here. What about in this one? There's a whole number in front of them, but what's it missing?
The decimal.
Missing the decimal. So therefore, how many sig figs do we have?
Just 1?
Just 1. 1 sig fig. Okay. And since you asked earlier about decimals, okay, and we're going to get into the math right now, but let me just go through this. How many decimals are in this number right here, 101?
There's no decimals.
No decimals, so 0 decimal places. So this answer is reported with 3 sig figs, but 0 decimal places. Okay, it has 0 decimal. And the same thing for this one here. There's 0 decimal places in those 2 numbers. So they're reported to this amount of sig figs, but no decimal places. Okay. Now, if I look at this one, how many places after the decimal?
1.
1. And this one?
There's none.
None. What about this one?
There's 2.
Okay, perfect. Yeah. So those are places after the decimal. And if I look at this one, even though these numbers are not significant, those zeros, they're still places after the decimal. So this one has 1, 2, 3, 4, 5, 6 decimal places. And this one doesn't have anything, so this would be 0 decimal places.
So then, if we were to have to, like, say we were to get an answer like that and it were to have us round to like 3 decimal places, what do we do then?
So an answer like this one or this one?
Like that first one, 0.000169.
So round to 3 decimal places.
Yes.
So in this case, you're going to actually have to convert it to scientific notation.
Got it.
So in order, because you, this is a good one because you see how these ones, you can't round anything there.
Mm-hmm.
One doesn't start until the 4th place. So in order to do this, you must convert to scientific notation. Right? And the way we do that is we look at that decimal, right? That's right here. And we're going to move it until it's behind a whole number. So that's 1, 2, 3, 4 spots. So my answer is going to be 1.69. I'm going to leave a little space right here for a reason. Times 10 to the negative 4 because it's a number less than 1. So if your number is less than 1, then this is negative. If it's 1 or greater, it's positive. Now I left the space here because it said round to 3 decimal places, right? Well, we only have 2 decimal places. So what can I add to make it 3?
Would it be another 0?
A 0, correct. So now our answer has 2
So
decimal places.
so we wouldn't add that 0, the answer would be wrong then, right?
Correct. If you don't add the 0, you have 3 significant, without the 0, you have 3 significant figures, but only 2 decimal places. With the 0, you have 4 significant figures, and 3 decimal places. So let's do a little bit of the math when it comes to reporting significant figures. We could do addition and subtraction. And then we're going to do multiplication and division because the rules are slightly different. With addition and subtraction, you report answer based on least amount of decimal places. Now remember, you don't do this until the end of your entire problem, right? So if your entire problem only has addition and subtraction, then you're going to report your answer to the least amount of decimal places. And if your problem starts adding multiplication and division inside of it, then you have to report it the other method, right? Because we're going to follow those rules, the please excuse my dear Aunt Sally rules, or just like pandas rules, parentheses, exponents, those kind of things. All right, so with these ones, you report it to the least amount of decimal places. So an example is if I have 200.000 plus 10.05, right? I'll get 210.050. Is that final answer correctly reported? What is the least amount of decimal places we have? We have 1,
It would be 2.
correct. We have 2. So therefore, we don't report that 0. And our final answer would be 210.5. So anytime you're doing these problems with the decimal places, you report it with the least amount of decimal places. So if I had 200 plus 10.05, and I get 210.05 as my final answer, well, what's the least amount of decimal places that I have?
0.
0. So because it's 0, that means I don't report these. Now this 0 cannot round anything, so I'll just drop it. And my final answer.
If it were to be like say a 6, 210.65, it would move it up to 211.
Yeah, so let's say we had this. Your 6 would round it. You are absolutely right. So it's going to round that up, and you're going to get 211 as your final answer. All right, so now let's look at multiplication and division. So with multiplication and division, we report answer to least amount of sig figs, significant figures. So in that case, if I have 200 times 2, right, I will get 0, 0, 4, 400. How many significant figures do I have in 200?
1.
1, correct. So there's 1 in this one. And the number 2 is basically just 1 sig fig. So my answer has to be reported in how many sig figs? 1.
In 1?
Yeah, that's right. 1, because it's the least amount. And this answer is also reported in 1 sig fig. So that answer is correct. Now, if I would have added a decimal there, that would have turned this suddenly to 3 significant figures, and the answer would be incorrect. It wouldn't be reported correctly, basically. So let's do another one. Let's say we have, I don't know, 15 times 2 divided by 2.0. Okay. All right. 15 times 2 divided by 2.0. Well, 15 has 2 significant digits. 2 has 1. 2.0 has 2. And to make our math super simple and easy, 2 divided by 2 is just 1. They cancel each other out. And our answer is 15. However, what do we have to report? Let me put this in this color. What do we have to report our answer in?
Just 1?
Perfect. Yeah, we need to report it in 1 significant digit. We have the answer of 15. That's 2 significant digits. So how can I report 15 into 1 significant digit?
That's where I get stuck.
So this one right here, the 5 rounds up the 1 to a 2. And you report it as 20. So as we can see here, because of the lack of decimals in some of these, a lot of these answers can be precise, but they're not accurate, right? 15 is way more accurate than 20. And as you lose significant figures, you lose your accuracy. So that's why significant figures are important. It lets us know how accurate we are or how precise we are. So 400 is a very precise number, it's a precise number, right? But if I say I have about $400 in my wallet, right? I started off with $400. I went shopping, bought some ice cream, saw a movie. I still have about $400 because I didn't spend that much, but I don't exactly have $400, right? So this is like it's a precise number. Okay, it's an estimated number because it's only 1 significant figure. Okay, well, this one right here is more accurate. You know, I'm saying I have $15 versus like I have about $20. To make the 20 more accurate, you would, like, if you knew you had exactly 20, you would add a decimal behind it to signify you have exactly 20.
So if our answer there would have been, say, 13, would it have just rounded down to 10 then?
Yes.
Oh,
Okay.
yeah.
That's a good question. So if your answer, you know what, I don't know how to make that 13. Oh, actually, let's do that. Let's do 15.
Or just like a number where you wouldn't have to round up, you know?
Minus 2. All right. So we do all the multiplication and division, and then we subtract 2 from it, and that was going to give us 13. Now, following our rules, right? Please excuse my dear Aunt Sally. Subtraction is the last thing we do, but because the multiplication and division were the leading factors in this, right? We're gonna follow the least amount of sig figs, and we get 13 as the final answer. And we want 1, so it would be 10.
Okay, now it makes sense.
So when you have your problems, right, like on the test, the biggest ones, there's people got partial credit. I went through today and gave partial credit. So if their answer, it said report to 3 sig figs, right? Okay. Now, if they gave me 19.1, that's 3 sig figs. Actually, it didn't say report to 3 sig figs. It said report to 3 decimal places, which is different. Okay, so it said report to 3 decimal places. 19.1 gives 3 sig figs, but only 1 decimal place. So how can I turn 19.1 to make it correct to 3 decimal places?
You would add 2 zeros at the end?
Yeah, 19.100. Now that would be correct. I guess feel free to jump in and like ask your questions or anything, try to get your clarifications. Everyone else here, Andre, Valerie, do you guys like have any questions on it?
Well, not anymore because you answered my question on discussion. So I decided to tag in just to see if I can learn anything else that I need to.
Yeah, oh, ask away.
Yeah, same with him. Pretty much everything you're going over right now makes sense. Typically I have questions as I go, mostly in the labs.
Mhm.
But as for right now, the same thing as Andre said, just kind of hopping in to get extra knowledge that I may have misunderstood.
All right, that works. How were you guys with density? Should I cover density a little bit?
I
Yeah.
don't think it would hurt for you to cover it.
Okay.
Yeah.
All right. So density is mass divided by volume. Okay. And this equation for me is super, like, when I used to teach high school, I used to tell them how to memorize it. And I said, well, I'm like, Andre was dating this girl called Destiny, and destiny to him equaled love. And he was so in love with her. And then one day, Destiny went, Andre, I don't like you because you're a dog person and I'm a cat person. And she left Andre and broke his heart. And that became mass divided by volume. So that's just a little story. And if you ever need to like memorize it and you're like, what happened? You could always think about Andre's heart being broken by Destiny. And then you get mass divided by volume with it. So it's always nice during Valentine's.
That's cute. I like it.
All right, Andre, hope you don't mind I used you.
No, it's fine.
All
It's
right.
just a story.
All right, good. I'm glad you like the story. So mass and volume are 2 different things, right? So mass is equal to the number of particles in something, all right, in a substance. How much do we have in it? Well, volume is equal to the space, the amount of space. taken up. So let's see if I'm gonna try to make 2 examples. So here I have lead, metal. And here, let's have, I want to say styrofoam, but I don't know how to spell styrofoam. All right, we're just going to use styrofoam, and I'm going to probably spell it wrong. Styrofoam. Okay, I'm not sure if that's right or wrong. But, right. We're going to pretend that both of these are the exact same size, okay, like the squares or the containers. And in this container, I have, let's see, I filled both of them up to this line, okay, with lead and styrofoam. Now, if I look at the molecules inside of lead and styrofoam, the molecules for styrofoam are very spaced out because there's a lot of air in between them. The molecules for lead, for metal, are very, very compact together. Now, I'm just going to do this for now because it will take me forever to draw circles. So we're going to pretend they're circles there. All right. Now, which one of these two has a bigger mass?
The lead.
Lead. Yeah. So this one has a higher mass. And that's because the molecules are more compact. While this one right here has a lower mass. And the molecules are less compact. Right? Now, since I filled them both to the same level, which one has the biggest volume?
What did they be? Go?
Yes, awesome. All right, I was making that my trick question, but you got me. All right, they both have equal volumes. Because they're both filled to the same level, okay, 2/3. 2/3 of whatever this is, right? Now, if I wanted to calculate the density of both of them, right? Let's say 2/3 was 750 milliliters, right? That's how much 2/3 was. 750 milliliters of a 1 liter container. And the mass of this one is less and the mass of this one is more. So I'm just going to give them random numbers and say that the mass of my styrofoam is 100 grams and that the mass of my lead is about 600, let's go higher, 800 grams because lead is very heavy. Okay. So now we have some numbers to work with, right? Volume is 750. Mass is equal to 100 grams and milliliters. To calculate density, right? Destiny broke my heart. It's going to be mass divided by volume. So we're going to get 100 divided by 750. And I get 0.133 something. And we'll worry about sig figs later. I want to teach the concept first. All right, so now let's do the density for this one. What do I have to do to this one to get the density? What goes on top?
600?
The 800.
Yeah. I turned it into 800. Sorry.
Oh, sorry. 800.
Yeah, it was hard to see. So yeah. So the 800 goes on top because that's our mass. And what goes on the bottom?
750.
Yep, the 750. So the density of my made up numbers are 0.133 grams per milliliter for styrofoam, and 1.06 grams per milliliter for lead. Now, lead is much heavier than that, so my numbers were actually, off. That's why I want to make sure I note that these are off numbers. But even so, we could still see the big difference between both of these. Right. Now, something you should probably memorize, they'll make easier to now and in the future for other classes, is that the density of water is equal to, 1 second. Sorry, child alert. The density of water is equal to 1.00 grams per milliliter. Okay, so if you're above 1, you're going to sink. If you're below 1, you're going to float. So will styrofoam float or sink in water?
It would float.
It's definitely gonna float. You're down here, you'll float too. All right, and this one, I know it's not like that much greater, but it's slightly there. What's it gonna do?
It'll sink.
It's gonna sink. Are you guys getting the child alerts?
Yeah, I got mine.
All right. Okay, so calculating density is literally just knowing mass divided by volume. But what if we don't have mass? What if we don't have volume? What if we have density instead? What if I said calculate the mass of an object that has a volume? I'm going to be very straightforward with this one. Has a volume of 150 milliliters and a mass of 25 grams. Okay, so we want to calculate this. The first thing you want to do is write your equation down. Density is equal to mass divided by volume. Note that we're going to calculate for mass, right? That's what I want. I want this. I have 150 milliliters, and that's my volume. And I have, oh, sorry. And the volume, I'm calculating. And the volume is grams per milliliter. Did I say volume twice? Sorry, child alert things like really throw me off. So the density, it has a density of 25 grams per milliliter. All right, now that I made a mess of the question. Yay. All right. So we want mass. The object has a volume of 150 and a density of 25 grams per milliliter. So this is what I want, mass. So all we have to do is move our equation around, right, in order to solve for mass. The way that I'm going to do that is quite simple. To get rid of volume at the bottom, I'm just going to multiply both sides by volume. That cancels volume out, right? It just goes to 1, because anything divided by itself is just 1. So that gives me mass is equal to volume times density. And with that, I'm able to actually easily solve the problem. Now, I like to manipulate my equation before I put numbers in, just so that I know that I'm putting everything in the correct spot and I don't mess up when transferring my numbers. But you do your math the way that you're more comfortable with. So I have 150 times the density of 25, right? So I'm going to put that on the calculator. Oops, 150. If I could do this right, 150. Nope. Anybody do it already?
No, I've been writing it down.
Okay. Well, I got 3,750, and please make sure verify my word, And let's look at the units. 150, so this was in milliliters. and my density was in grams per milliliter. Okay. From here, I could see that milliliter is on top and it's also on the bottom. So therefore, milliliter and milliliter can cancel out, right? They're divided by each other, so that means it's just a 1. And I'm left with the unit of grams. Is grams the unit that I want? Yes, it is. Okay, it's what I want because I'm asking for mass. I want to know what mass is, and the unit of mass is grams. All right, is my answer reported to the correct number of significant figures?
Shouldn't it be 2?
That's right, it should be 2, because we have 2 significant figures here and 2 significant figures here. So my answer needs to be reported to 2 significant figures. That's where that 7 is at. Right next to that 7, after that 7 is a 5. So the 5 is going to round it up. And therefore, my final answer is going to be 38,000 grams. Find space to put my stuff in. I want to show you guys a problem I saw in the book. That's quite simple. It's not a density problem. It's a different problem, but see if I can move this here. All right, so it's a little bit hard to read, but this one is about exact numbers and measured numbers, right? So this is something you guys did in the lab. So I'll read it out loud. It says, a dairy farmer reads a study that says lactating cows that are producing milk, consume an average of 27 pounds of dry hay each day. The farmer has 44 cows and projects hay cost based on these numbers. Which of these values is measured and which is an exact number? So which number is the measured number?
Um, 44 cows.
I think it's 27.
Okay. So the measured number is going to be his averaged amount that he gives. He's measuring about how much they're going to be using, right? So it's 27 pounds, measuring by seeing how much they're consuming. The number 44, he has exactly 44 cows, right? We could say, oh, cows consume 27.5 pounds, right? And that would help us see that it's a measured number. But can you say he has 44.5 cows? I mean, if they're living and breathing, you know, not like chopped up or anything, you know. So, sorry, I know I get the what if kind of question. So the 44 cows is an exact number, right? It's like I could say an exact number is I have 38 students. I don't have 38.5. I don't have 37.2, right? Because that would mean there's part of a person somewhere, right? Alive taking my class. And if you are alive, you are a person, a whole person. So I have 37 people. He has 44 cows. That's exact. Measuring about 27 pounds used. It's like if you go to the store and you buy You say, I want 2 pounds of salmon. That's in measured number. Oh. You guys, any other like questions or little clarification things? Let's see if there's anything in the book.
I feel like I'm pretty good with conversions, but I get like stumped when it's a conversion and then um like they're two different units
Okay.
and I don't have the conversion rate for it. Sometimes like I try to find it and I can't find it. And then that leaves me like unable to do the problem correctly.
So, in your textbook, the online one, they have forget what it's called, but there's a little section where you click on it, on Achieve, and it's gonna pull up all these metric charts for you, like everything that you need. I just have to remember what it's called.
Oh yeah, is it like SI units or something like that?
Yes, there's this SI units, which is the standard international units. But following that on Achieve also though, I mean, every single kind of reference sheet that you're gonna need is on there. So that's probably the best thing if you play around with Achieve. And
Yeah, I'll probably have to search for that to make sure to find that.
and when you find them, just print it out, you know, and have it available to you, have it readily available.
Yeah.
Trying to see if I find it, an appendix of it on the book. Glossary. But we'll go over one of those problems and work it out. Let's go over the quiz problem for it. There was a quiz one like it. See if I could open it up. Give me a second. Okay. Man, the computer is really slow right now. I think it's because I have too many things opened. All right, it's getting it. Okay, here we go. So I'll write that question down. It was question number 8, I believe. So it says a candle made of a certain wax burns at a rate. And then it gave a random number to different people. So I'm just gonna say it burns, excuse me, at a rate of 700 milligrams per minute. What is the value of the burn rate if expressed in grams per hour? So it wants you to express in grams per hour. And then, sorry, I'm gonna sneeze.
God bless you.
Thank you so much, appreciate it. And it says give answer in 2 decimal places. All right. So starting off, we know we have 700 milligrams per minute. So that's what I'm going to start off with. Always start off with my given. I'm going to write my units down per minute. I like to put my things in parentheses. I also like using other methods to solve this. And this is to me a clean method, right? That we could all see. So I have 700 milligrams on top and a minute on the bottom. I need to change milligrams to grams. Okay, so that's step one, milligrams to grams. Okay, now in 1 gram, there is 1,000 milligrams. That is an exact conversion number. Okay, in 1 gram, there is 1,000 milligrams. Right, so I'm going to turn it into an equality, and by placing 1 on top and 1 on the bottom. Okay, now I want to get rid of milligrams. So which one of these has to go on the bottom?
The milligrams.
Correct, the milligrams, because I want milligrams to cancel out. The other way of noting is if you have something, bring it to the opposite, right? So you want to do something like that. All right, so I'm going to write milligrams on the bottom in order for it to cancel out, and a 1 gram on the top. So I have 1,000 milligrams. Ignore this one. I don't want you guys to get confused. All right, so I have in 1 gram, I have 1,000 milligrams. Now, milligrams cancel out with milligrams, right? So milligram divided by milligram is equal to 1. Right? That's like infinity divided by infinity is equal to 1. 1 divided by 1 is 1. Okay, so milligrams cancel out, and now I have the unit of grams, which is exactly what I want. Okay, now I also need to convert my minutes into hours. Okay, so I need to convert minutes into hours. Why can't I HR hours? Okay, so in 1 hour, there is how many minutes?
60.
60 minutes. Now, same process. I want to get rid of minutes. Minutes is on the bottom, so therefore, where does minutes have to be on this one?
On the top.
On the top, yeah. Minutes goes on top. And my hour goes on the bottom, and I'm going to fill it in 1 hour and the 60 minutes. Notice that the bigger unit, I always give the bigger unit the 1. That makes it a lot easier for me. I don't like working with the decimals. You could say 1, I don't know. I don't like doing that. So I always give the bigger unit the 1, and then the smaller unit gets how many of these small units are inside of this big unit, right? How much of this can I fit into that? Okay. All right, now that that's there, you notice that minutes also cancels out with minutes. I'm left with grams per hour, which is exactly what I want, the grams per hour. And now it's just a matter of calculating and just multiply everything on the top and divide by whatever is on the bottom. Okay. Grab your calculator, and since this is just multiplication, it doesn't have to be fancy or dancy. So I'm just going to have 700 divided by 1,000 times 60. And I get 42. Oops. There we go. And final answer of 42. It wants me though to express it in 2 decimal places. Is this in 2 decimal places?
No.
No. What do I have to do to make it 2 decimals places?
Add the 0.
Now, do I just add zeros like this?
You have to add the decimal point.
Correct. Now, that now is the correct answer. 42.00 grams per hour. I want to do something really quick, a little bit apart from this, just because it occurred to me here. When I said, do I add the zeros here? Okay. You guys were like, no, that was a good response. All right, I want you guys to think about this as money. Every time you guys think of numbers and you're having a hard time deciding, is it bigger, is it smaller, or anything, in your scratch notes, not in your answers, but in your scratch notes, put a dollar sign in front of it and watch it make sense. Okay. This is $42. If I add 2 zeros after that, all of a sudden I have $4,200, which I wish I had, but $42 is more of what I have, 4,200. And this is also $42. This is just an exact number, right? This is saying I have exactly $42.00. Here I have about 42. Here I have $4,200. So, that's why that decimal is very important. Did it help going over this problem? I know I sidetracked a little.
Yeah, it definitely helped.
If there's another one you see that you want me to try, let me know.
No, yeah, they make sense to me. It's just I just have to find that chart.
Yeah, just conversion charts. Let's see. In my book, I have the, I don't even know what edition I have. I have an old edition. I think I have the 7th edition of Revell, or the 6th. But if you go to even on the online one on Achieve, table 7.2 has common conversions. So for chapter 2, if you see, go to table 2.7. You'll see common conversions for there. Table 2.6 has common densities. I want to find the metric conversion for you. Okay, 2.5.
Okay, got it. Thank you.
Yeah, so just open up the tables on your online book, print them out, print them out and put them with your notes. That is the best thing to do.
Definitely.
So here's an example of like one of the classes that I'm currently taking. And I print out my like sheets and I put them out here in the front, but I also print out all my PowerPoint. Okay. And then I watch the video lectures and take all my notes on the PowerPoints that I have printed out. Right. So practice exams, everything, like I print it all out. I know it can be a hassle sometimes, but everybody learns differently, right? And if this is something that might help you, like I like to share that technique. Someone told me to do this and it made my studying so much more better. To just keep it organized in a notebook, print it, write on it, put all your charts on it. Yeah, I was relying on my online PowerPoints too much, and no, that wasn't helping.
Yeah, being organized is definitely a big one.
Yeah, it takes some time. You just take a moment and then like an hour, and just start print it out at the library, at home, or whatever, wherever you can. Can you guys think of another question? While you guys do that, I'm just gonna quickly go over then, while you're looking or thinking, powers of 10 then. All right, so if I have 10 to the 0, what is that number?
1.
Itself?
Actually, it's 1. So this is 10 to the power of. So if it was like 10 times 10 to the 0, then the answer for this would be 10, because this is 10 times 1, and that gives you 10. So it's just like a little common thing to see. The other thing I want to show you guys, I think I showed it in one of my lecture notes, but let's do that again. It's when we're talking about powers. If I have 10 to the any number x times 10 to the y, that is the same as saying 10 to the x plus y. So an example would be 10 to the negative 6 times 10 to the second, right? That's going to give me 10 to the negative 6 plus 2, which would give me 10 to the negative 4. And how you would see this is if you had significant numbers, for example, like 2 times 10 to the negative 6, times, I don't know, let's just keep it easy, 2 times 10 to the negative to the 2, right? Since we already did that one. Okay, and you're like, okay, I don't have a calculator, I forgot, or you just want to do really fast math, right? Well, 2 times 2, 4. And 10 to the negative 6 times 10 to the negative 2. Remember, that's the same as 10 to the negative 6 plus 2. So that gives you 4 times 10 to the negative 4. And that would be your answer in scientific notation. And if it said reported in decimal notation or standard notation, well, you just take it out of significant scientific notation by moving a decimal. So remember, there's always an understood decimal behind here. Even if you can't see it, it's understood, right? So that understood decimal, we're going to move it over 4 times. Now, because this number is negative, is the number going to be smaller than 1 or greater than 1?
Smaller.
Yeah, it's going to be smaller than 1. So I'm going to take this understood decimal and I'm going to move it 1, 2, 3, 4 spots. So that's going to give me 0.0004 as my final answer. If I were to move it, I mean, obviously it's just an example. So that is very useful to know. The other one is 10 to the x divided by 10 to the y. That is equal to 10 to the x minus y. So let's use the same numbers that we have here. If I had 10 to the negative 6 divided by 10 to the second, that's going to give me 10 to the negative 6 minus 2. My answer is going to differ from the answer up here because now I have 6 minus 2, which is going to give me minus 8, negative 8. So using the same numbers, but now I'm going to put them in division form. 2 times 10 to the negative 6 divided by 2 times 10 to the second. Well, easy math, right? 2 divided by 2 is 1. And now we know that 10 to the negative 6 over 10 to the second is negative 8. So this number is way smaller than that number, drastically smaller. Other. So that would probably help you with any math class that you're gonna take in the future as well. A little handy dandy trick.
If we were to write like that answer up on top where it's 10 to the negative times 10 to the negative 4, if we were to write 0.0004 as opposed to 0.0004, would that mark it wrong?
No, so if this versus this,
Yes.
no, they're equal.
Okay.
Those two are equal answers. They're both standard notation. These zeros are not significant. So you're just putting your placeholder down right there. It doesn't add to the decimal place either. And then jumping back on this, I know we already covered it, just so I could write it down. Remember, if you have 10 to the negative x, that means your number is smaller than 1. And if you have 10 to the positive x, your number is 1 or greater. I know you could do the little mouth things like the side V's and stuff for this, but I always get confused. That would be less than 1, and this would be greater than or equal to 1. I think that's it. And I think the only thing we haven't covered for chapter 2 is temperature now. And well, temperature is just having those equations down and being able to convert from plug and chug, basically, convert from one unit to another. Know that Fahrenheit is used in questions, but we don't use it in actual chemistry. So Fahrenheit is used for the weather, right? Celsius is used for anything with liquid, and Kelvin is used for gases. So that's a neat little fact about our temperature scales. All right, any other questions, you guys?
I don't have anything. I want to thank you though for all your help.
You're welcome. And remember, if there's ever you guys have questions or anything like that, if you email me directly, send me a Snapchat, oh my God. Send me a picture, right? A screenshot of what you are working on or the concept on or anything, as long as it's not a test, right? And I will help you out the best I can with it without giving you the actual answer, but actually explaining to you how to do it. So feel free to, when you're stuck, shoot me an email with a screenshot and I could help you right away. Because I'm not always with the computer. This is my part-time job. So I do have a full-time doing something else. And when I can help, I will help.
Sounds good. Thank you.
Of course. All right, with that then, I'm gonna go ahead and close this up. You guys have a wonderful night.
Okay, thank you. Bye.
You too.